Welcome to the module on Introduction to Predictive Analytics. In this video, you'll learn about Pearson's correlation and how to conduct it on Excel. Correlation is a relationship or association between two variables. What I mean by a relationship is when a change in one variable is associated with a change in another variable. For example, there's a relationship between hours spent studying and test performance. So a change in hours spent studying is associated with a change in test performance. Typically, the more people study, the fewer incorrect answers they have. There's also a relationship between price of home and days on the market. So a change in one of these variables is associated with a change in the second variable. Typically, more expensive homes take longer to sell. There's different types of relationships. We can have a linear relationship or a curvilinear relationship, and this can be determined by creating a scatter plot. A linear relationship is one that's best represented by a straight line. So if you create a scatter plot, you'll see that the dots on the scatter plot are forming a straight line. So if you were to draw a line through the middle of your dots, it would be straight, and it would go up to the right or down to the right. A curvilinear relationship is a relationship that's best represented by a curved line. So if you had to draw a line through the middle of your dots on a scatter plot, you would end up forming a curved line. There are many different types of curvilinear relationships. Here's two examples on scatter plots. The chart on the right is a classic example. Many people might be familiar with this, especially athletes. It's the relationship between anxiety or arousal and performance. So typically when arousal is low or very high, that's when performance is at the lowest. People tend to perform the best when they have moderate levels of anxiety or arousal. In this class, we're going to focus on linear relationships. And specifically, we're going to focus on Pearson's correlation. This is the most common type of correlational analysis. It's the most popular. And it's used to detect a linear relationship between two quantitative variables. So in order to conduct a Pearson's correlation, you have to have two quantitative variables. When you conduct this analysis, you are going to get a correlation coefficient. This is called Pearson's R. It is a number, and it can range from -1 to +1. And this number gives you information about the relationship between the two variables. Specifically, it describes two aspects to the relationship. First of all, the sign of the coefficient, whether it is positive or negative, indicates the type of the relationship. So there's two types of relationships, a positive or a negative relationship, and the sign indicates the type of relationship. And then the numerical value or the actual number of the coefficient indicates the strength of the relationship. I'm now going to go into more detail regarding these two aspects. So again, the sign of the coefficient, whether it's positive or negative, is going to tell you if you have a positive or negative relationship between those two variables. If your value is negative, you have a negative relationship. And that means as one variable increases, the second variable tends to decrease. And this is what it looks like on a scatter plot. So if you plotted it out, your dots would slope down to the right. An example of a negative relationship is the relationship between product availability and consumer interest. So decreases in the availability of a product is associated with increases in consumer interest. So you can see that when availability is low, consumer interest is high. Then increases in availability is associated with decreases in consumer interest. So a negative relationship is when the variables are changing in the opposite direction. If your Pearson's R or coefficient is positive, that means you have a positive relationship. A positive relationship is when the variables are changing together in the same direction. So as one variable increases, the second variable tends to increase. You can also reword that to say as one variable decreases, the second variable decreases. Again, a positive relationship is when the variables are changing in the same direction. If you plotted your data out on a scatter plot, this is what it would look like. The dots slope up to the right. An example of a positive relationship would be the relationship between price of a product and then perceived quality of a product. So you can see that increases in price is associated with increases in perceived quality. Likewise, we could reword that to say decreases in price is associated with decreases in perceived quality. Again, it's a positive relationship, so the variables are changing together in the same direction. If you have a Pearson's R that's very close to 0, so it's not really positive or negative, that means that there is no relationship between the variables, or there is 0 correlation. When you have a 0 correlation and you plot it out on a scatter plot, you can see that the dots aren't forming any kind of line. It's not going up to the right or down to the right. An example of 0 correlation is the relationship between shoe size. So increases in shoe size is not associated with either increases or decreases in IQ. The second aspect of a correlational relationship is the strength of the relationship. And you can indicate the strength by the actual value, the actual number of the correlation coefficient. So again, the correlation coefficient ranges from -1 to +1. And the closer that the value is to either negative or +1, the stronger the relationship is. I recommend when looking at the strength, just ignore the sign. Just look to see how close the value is to 1, and the closer it is, the stronger the relationship is. And here's a chart that you can use to categorize the strength. So if it's 0 to 0.19, you have no to very weak relationship. 0.2 to 0.39 is weak. 0.4 to 0.59 is moderate. 0.6 to 0.79 is strong. 0.8 to 1 is very strong. And the strength of the relationship is how strongly associated those two variables are. And the more strongly associated they are, they're going to make a line, kind of like a straight line on a scatter plot, and they're going to be very clustered together. So you can see that as the correlation is getting closer to 1 or -1, the dots are forming this nice straight line. The dots are very clustered together. The closer that the correlation coefficient is getting to 0, the more spread out the dots are. There are 2 ways to conduct a Pearson's correlation on Excel. One way is using a function. So the function is the CORREL function. And what you do is you just select your 2 variables and do not include the headings. And the second way is you can use the data analysis toolpack. When you do that, you would want to include the headings. So now I'm going to show you how you can do those in Excel. So you can see here we have a data set from a company. They have different employees, the number of days they missed, the number of sales calls they made, and the number of copiers that they sold. So first I'm going to show you how you can do the function. So in this first cell, we are going to conduct a correlational analysis between sales calls and copiers sold. So again, we use our CORREL function. And then we're asked to indicate the 2 arrays or the 2 variables that we want to analyze. So we're going to look at sales calls, do not include the headings, and then copiers sold. And here is my Pearson's R, or my correlation coefficient. And after we're done conducting the analysis, we'll talk about what this value specifically means. Now we're going to do the correlation for days missed and copiers sold. Again, our CORREL function. I'm going to select days missed and copiers sold. And I got -0.2398. So this is the function. You can also use the data analysis toolpack. So I'm going to open up the data analysis toolpack. And I'm going to select correlation. And the good thing about the data analysis toolpack is you can select multiple variables at once. So we're going to select all of the variables, or all of the quantitative variables. So for our input, we're going to select all of the quantitative variables. Remember, correlation is quantitative variables only, so we can't include any qualitative information. and I included the headings. Because I included the headings, I'm going to check labels in the first row. And then now I need to tell Excel where to put the output. So I'm going to click on output range, and I'm going to click on that yellow designated cell. Again, it's really important that you put the output in this specific spot. And then we're going to get a warning. We're going to hit OK. All right, here we go. All right, so this is what the output looks like. Ignore the ones on the diagonal. We can look at the values. So this right here, this is the correlation coefficient between days missed and sales call. Right here, negative 0.2398, that is the correlation coefficient between days missed and copiers sold. And then right here, this 0.71985, that is the relationship between sales call and copiers sold. So you can see that we got the same value up here. So the good thing about the data analysis toolpack is you can select multiple variables and really quickly you get the results. The downside is that if you have to update the data in any way, you have to rerun the data analysis toolpack. That is the positive of the function. Once you update the data, the function automatically updates. However, with the function, you have to write a separate function for each pair of variables. All right, now we're going to spend a little bit more time interpreting what these numbers mean. So question 1 asks, what type of relationship is there between sales called and copiers sold? So you can see that right here, it's 0.71985. It is a positive value, so that means we have a positive relationship. Remember, the sign of the coefficient indicates whether you have a positive relationship or a negative relationship. A positive relationship is when the variables are changing in the same direction. So an increase in sales called is associated with an increase in copiers sold. Remember, we could also reword that to say decreases in sales call is associated with decreases in the number of copiers sold. So for number 2, that's going to be A and C. So A and C are describing a positive relationship, so we are going to pick E. So questions 1 and 2 dealt with the type of relationship, whether it's positive or negative, and remember that's indicated by the sign of your Pearson's R or your coefficient. Question 3 asks, how strong is the relationship between sales call and copiers sold? And remember, this is indicated by the actual number. So you look at the actual number and you ignore the sign. So we have 0.71985. And we can use this scale to categorize the relationship, and you can see that we would fall right here. So we would have a strong relationship. So the correct answer is D. The last 3 questions deal with the relationship between the number of copiers sold and the number of missed days. So you can see that that was negative 0.239. Here it is for the function. Here it is on the output. So our value is negative, so that means we have a negative relationship. So the answer to question number 4 would be B. Remember, a negative relationship is when the variables change in the opposite direction. So increases in the number of copiers sold is associated with decreases in the number of missed days. So that would be B. So the answer to 5 is B. Question number 6 asks how strong the relationship is. Remember, to figure this out, we look at the number, the actual value of the coefficient. We ignore the sign. So our number is 0.2398. And then we can use this chart, and you can see that would fall right here. So we have a weak relationship. So the correct answer would be B. The last thing we're going to do is create a scatter plot between sales call and copier sold. So I'm going to select the data for those two variables. I'm going to include the heading, and I'm going to go to Insert, and I'm going to choose the scatter plot right here. And we want to move the scatter plot down. Sometimes what I think is easier rather than dragging it is just to cut it and then paste it. So to cut it, I'm going to do Control X. So Control X or Command X if you're on a Mac, and I'm going to scroll down here, and then I'm going to hit Control V or Command V. It's just kind of easier than dragging the graph around. All right, we want to modify the title to say sales calls and copier sold. Then we want to insert axis titles. So to do that, I'm going to go to Chart Design. I'm going to go to Add Chart Element, and I'm going to go to Axis Title. I'm going to do the horizontal first. And what I'm going to do is I'm going to reference the variable name. So after I click on this, I'm going to immediately hit equals. So I'm going to click on this and then immediately hit equal, and I'm going to scroll up and I'm going to click on sales call. If it didn't work, it's probably because you clicked on something else or you touched something else. You have to immediately hit equals and then reference your heading in order for it to work. If you can't get it to work, you can always type it in. That's fine. This is just a really quick, easy technique that I want to show you. So now I am going to, again, Chart Design, Add Chart Element, and now I'm going to do my vertical axis title, and again I'm going to immediately hit equal, and now I'm going to reference copier sold and hit equals. I like to insert my chart titles this way, or sorry, my axis titles this way. I think it just makes it a lot easier. All right, the last thing that we want to do is do the source. So I'm going to go to Insert, Text. We're going to insert a text box. Insert it right here. And we have our source, which is copier sales. All right. So again, we have a positive relationship between sales calls and copier sold. So you can see that the dots are forming this line that goes up to the right.